Good morning, everybody. So today in Joe's garage we have an LG front loader direct drive washing machine. This was given to me by a friend. I don't know too much about it other than it's 7 years old and supposedly has drain problems. When I arrived to pick it up, the inside had several gallons of water and a couple of clothes, but we won't get into that. So really all I've done so far is I've opened this door down here. I've let the water drain out of this hose all the way at the bottom, which you probably can't see. Down here. Let the water drain out of here and just pulled this this filter plug down here, just unscrews to get any remaining water out. So all I've really done is made sure the thing was dry because I knew it was going to sit in the garage for a while. Have not plugged it in, but I do have my washing machine testing apparatus hooked up, which I will show you now. So to be able to test these things without hauling them inside, what I normally do is I'll hook up two old washing machine hoses, one of these little Y devices or Y splitters, and hook the other end up to a garden hose. I only get cold water, but that should be all we need to just test the thing out and see if it works. So really all we need to do now is hook up our garden hose, supply power, and make sure this drain hose is sufficiently outside and not near the inside of the garage. So I will take care of that now. Let's do our hookup here. Got my garden hose. Got a shutoff valve here too. These things are really nice. You pick these up on Amazon. I think it's 15 bucks for two of them. Really helpful for changing nozzles and whatnot. So we'll energize this. So the washer has water now. Let's make sure this drain hose is sufficiently outside. And we'll get our power hooked up. All right, let's give it power. Gonna hook this thing up and you guys will be the first to see what happens, if anything. Energized. So let's let it run through a cycle, I guess. Power, how do you turn it on? Power. Oh, how nice. So let's do maybe just a rinse. Oh, gotta close the door, I guess, right? Let's do, oh, boy, these are complicated. Oh, it's doing something. Let's do stop. I'll figure this out. Okay, it's doing something now. Sorry if these lights are giving you a seizure. It looked like there was some kind of weird syncing issue with the camera. Yeah, I just heard the water solenoid kick on for a second, so I'm going to let this run. You could probably hear it now. Okay, it's mad about something. LE. Okay, quick Google search indicates that a code LE is displayed when the tub fails to spin. This is right from LG's website. Error code indicates the motor can't operate properly because you've overloaded the washing machine or a foreign object is stuck in the tub. I don't think that's the case, but let's try. Tub seems to turn just fine. No resistance, but maybe this is the issue that we were having here. Let's press play again. Is it going to do anything different? All right, I hit resume. I saw the tub twitch there for a second, so let's see what happens. Seems to be adding more water now. All right, so after waiting a little bit longer, we're still back at flashing LE. So yeah, it seems like that's one problem for sure. The motor doesn't want to spin. So let's see if we can dig into that. Let me see if I can drain the water out of this thing first. We just cancel. Well, that's kind of dumb. So you can turn it off and it doesn't drain the water. Is it going to drain now? All right, it's draining. So it doesn't seem like our issue is with the drain motor. At least not right now. Although I don't see like a cancel cycle mode, I was able to put the the dial over here into tub clean, and it just rinsed out the tub, and I just killed the power in the middle of that cycle, and it does seem to be draining right now, actually. So I guess that's one way to drain it. So I could see how my friend thought that this was a drain motor error, because perception is, oh, I put the clothes in there, I hit start, it fills with water, and then flashing LE, right? So now I'm left with a tub full of water, and it doesn't go away. So I could see how he might think this was a drain issue, but in fact, this seems to be an issue with the actual motor. So since this is a front loader, the motor should be on the back rather than the bottom, so I'm going to spin the washer around, and we'll see if we can figure this out. Got the washer flipped around, and this is starting to make some sense now, because I see there's a screw missing here and here, so somebody's been in here before. I don't want this thing sailing away on us. It's on wheels. Just for my own sanity. Why am I using a manual screwdriver? One down below. Got those two screws out. This panel looks like it just lifts up, and there we go. So there is our motor in all of its glory. Get you guys a slightly better view. So I'm still struggling a little bit because I know the tub is not stuck. So we can spin this, no issues. I do see water tracks here, which is a little concerning, but that might be from up above. I wonder if this is maybe just a sensor issue, because if this thing rotates freely, it's not stuck. Maybe there's like a Hall effect sensor or something under here that's gone bad or not working properly. Let's take this rotor off and get a better view of things. On this machine, that's an 11/16 socket. And this should just come right off. Might have to, yeah, there we go. Gotta jiggle it a bit. Okay, so there's our stator right here. I see no obvious problems with it just looking. That's a big bearing. Wow, look at that thing. That's pretty serious. Thinking. I think we got to take this stator off. Is there supposed to be a bolt here? Let's get the stator off, and let's see if we can get a better view of what's underneath it. Like I said, I'm guessing there's a Hall effect sensor under there, so we probably need to get after that. I did check the parts diagram, and there is supposed to be another bolt there. So someone's definitely been in here before. Hey, bud. Sorry, the dog is very curious. Watch out. Excuse me. Again, just 10 millimeter. The fact that we see signs that someone's been in here before is pretty suggestive we're on the right track, right? Someone touched something before. Maybe they messed it up, right? I'm going to put a bolt back up in here. So I'm guessing they just lost that bolt. I left one in here because I want to make sure this thing doesn't just fall out and break any wires. So looks like we have some screws down here that hold a wiring harness. Let's take out the final bolt and just carefully take this thing off. Probably an expensive part. Okay, Okay, so there's a harness here. How does that come off? Looks like there's a couple of clips. So can we take that off while this thing is still assembled? Yeah, it comes off just fine. Just squeeze in these tabs and pull. Not too much resistance there. So I guess I'm a little confused because I see 3 wires here, but how does this thing sense the position of the rotor? Because I'm assuming that's what's causing the problem. There's another harness down here. Where does this go? There's some wire in a baggie here. Okay, so this is probably just the wire that goes to the actual rotor. Doesn't seem like there's too much else in it. Yeah, just 3 wires. But let's see, there's more wires that go to the front. So I wonder if there's like a rotor position sensor on the front. I would think that the position sensor would be here. A little confusing. Let me look at a parts diagram again because we had a screw missing. We know someone's been in here before, so I wonder if there's other parts missing that we're not seeing. Okay, I was able to find a service manual for this thing. I looked at a parts diagram. I actually didn't see any type of sensor back here, which is kind of surprising. Maybe there's a sensor elsewhere. All the ones that I've seen were on the back, but maybe this model is different. This is a model number WM3670HVA, by the way. Like I said, I did find the service manual. Apologies for the glare, but that's what it says for LE right here. So it seems to suggest a wiring issue somewhere between the PCB and the stator assembly. So we'll go ahead and we'll check these wires. Maybe this tub is going to move, so maybe there's some kind of an abrasion issue. I don't know. So let's take a look at the wiring really carefully. Manual does also have this nice troubleshooting guide here. Talks about checking the connectors at the motor drive, I guess the PCB right here. There's a little connector down there in a plastic bag. There is, I guess this is the one that actually goes into the stator. Checking for cracked magnets in the rotor and checking the resistance of the stator. I think I might start with that just because the stator is off. Pretty easy to check. It looks like they want between 5 and 15 ohms between all the windings, so all 3 connectors. So let's get the multimeter out and give that a check on the bench. All right, hopefully you guys can see the meter hanging on the bench there. I'm just going to check these terminals. I'm going to do the outer 2 to each other. Got 11 ohms. Left to middle, nothing. Right to middle, nothing. Let's do out to the test point. That's about 6 ohms. Middle to test point, nothing. Right to test point, about 6 ohms. Oh boy, so it looks like we may have a bad stator. And when I say test point, I'm referring to this piece right here. So just check left. It's about 6. Middle to that is nothing. Right to that is about 6 again. I'm just doing, that's about 11. Nothing. And nothing. So unfortunately we have a bad stator, and this is a pretty expensive part. As I was perusing the parts diagram, it looked like this was about a $200 part. So this might be a terminal problem, no pun intended, because I'm not going to dump $200 into this washer. Let's take a closer look at this thing and see if maybe we can fix it. Okay, so now I'm looking for obvious signs of a problem, like obvious burn marks. I don't see anything. Why is the meter complaining? Ignore that. I don't see any obvious burn marks on any of the windings. I mean, I don't see any noticeably loose wires, so visually it looks okay. I wonder if the problem's in this connector down here, or perhaps the connector for that middle terminal. Let's try something here. Can we hook onto that using the alligator clip? Probably not. No, I don't don't think we will be able to. What I'm going to try to do is see if wiggling any of these wires suddenly allows us to have a connection somewhere. So let's get these situated as best we can. Is there a way I can just kind of shove this in here? Maybe that works. Cool. So let's just gently poke at some of these wires with a screwdriver to see if suddenly we get a connection. I'm just poking real gently here. I'm not doing anything crazy. So it doesn't seem to be an obvious or like some kind of like a transiently loose connection. It looks like the wire for this thing goes to this coil right below it there. I'll just poke and prod around there, see if anything changes. Nope. This is a doozy. Okay, I discovered that this connector just kind of, this is a connector and not part of the coil. This just walks off, so I just walked it off with a screwdriver a little bit on either side. So let's repeat our test. Open, 6. Okay, so no difference really. So it rules out the connector as a possibility. I don't see any broken wires in here. Looking right here, nothing's really loose. And so the wire comes out of here, it goes into this coil, and goes over to another. Let's see if I can trace this. I have looked at every single coil pretty carefully. The only thing I see that's weird is this wire in particular seems very loose here and on the other side of the coil. So I'm wondering if maybe there's a maybe this wire broke right here and it's broken somewhere in this connector here. That's the only thing that I can think of, and it's much looser than any other wire coming out. So I'm kind of going to gamble here. I'm going to tug on this end of the wire and see if it just pops out or something. Maybe it's just manufactured that way, but it seems very loose. So let me work at this with you guys out of the way. That wasn't it. It was secure, but there is definitely something going on with this coil right here. I don't know if you guys can see this, but this wire down here is wiggling around like a loose tooth. I'm barely even moving it. So something's disconnected there. Let me see if I can find it. Been fighting with this coil for probably about an hour or so. Made an observation. So where these wires terminate at the terminal block here and in this common terminal here, I mean, the wires are basically falling apart. I mean, I just touched the terminal and wires fell off. So it got me thinking, like, what are these wires made out of? Because copper wire is usually a little bit more resistant than that to bending. And anyway, that got me thinking a bit more. And this thing felt kind of light. I felt these stator coils before. This thing felt a lot lighter than most stator coils I felt, like particularly out of Whirlpool machines. And I do actually have a spare Whirlpool stator coil, and it's about twice the weight as this. So then I stripped off some wire at the end here and down here. This wire is not copper. This looks like aluminum wire. That's just a horrible idea. Like, you just don't use aluminum wire in these types of applications where there's any sort of abrasion. I mean, aluminum builds up an oxide layer over time. Like, just a horrible idea. Why would you do that? So yeah, LG, not very good. I mean, this is an expensive part. It's $200. This is supposed to be a high quality part. So shame on you for using some kind of non-copper wire, likely, again, aluminum. So it's quite possible that there is a break somewhere inside one of these coils here that I just can't touch. I switched over to the fluke meter and I've been, banging this thing, tweaking these wires, trying to see the resistance change, but it's pretty locked on at about you know, 7 to 9 mega ohms on this terminal right here, this middle terminal. So I think this coil has, unfortunately, some kind of internal failure that I can't fix. I'm not going to unwind this whole coil, although I guess I could. That would be a lot of work. Let me think about what I want to do here. I definitely don't want to drop 200 bucks in this machine. It's 7 years old. All right, I'm about ready to cry uncle on this one. I can't figure out where this break is. I've checked every coil. It's every third. 1, 2, 3, 1, 2, 3, 1, 2, 3 that's on this middle circuit that's affected. I think it's scrap at this point. You know, if I can unwind it from here, you know, maybe this first coil and see if I can find a break. I mean, at this point, just for entertainment value, because this thing's junk. So let's see if we can find a break. And again, this wire is garbage. It's all aluminum. My guess is wherever there is a break, it's not going to be somewhere where we can see it or detect it. Because I've tried sending voltage through this thing, I've checked the resistance, I've shocked it, I've torqued it, I've tweaked it. Nothing really seems to pinpoint one of these coils over another. So the break is probably deep inside one of these. Watch, we'll get lucky and we'll find it right now. What garbage wire, man. Don't use aluminum for electromagnets. All right, so it looks like this particular coil is fine. I see no breaks in the wire. There's about a mile of wire in here. So we can feed this through. Next coil. My luck, it'll be like somewhere over here at the farthest point. All right, not in the second coil. Starting to get a little unwieldy, so I think we'll cut it. Now I suppose you could also cut each of these coils and isolate it, but there's not a lot of room here to like solder stuff back together once you find it. I wouldn't be surprised if that was this one right here, because there was some corrosion on this coil. I don't know if it was corrosion or just soap residue, but this is aluminum. Maybe something got in through the insulation and ate through it. I think it was this one and this one that had it the worst. Oh, there we go. There's our break. Look really carefully, you can see the other end of the wire right there. Got the other end of the wire broken out there. Let's test it to make sure there's no breaks, no more breaks in this coil. So I got the fluke meter hooked up. Just should be a bare end there. If not, we'll scrape it a bit. Put this on ohms, and then we'll flip it over, and we'll grab our ground connection here. Might need to burn this a little bit just to open and get a better connection here. Oh, we're getting 4.69 ohms. So they said between 5 and 11. So that's good. The rest of the coil is now good. So can we fix this thing? Can we fasten it back together? We're going to face a couple of challenges. One, soldering aluminum wire generally is not terribly fun. I don't have a lot of experience doing it, but I guess we could try. We're also going to have to insulate that soldered connection and then rewind all these coils as best we can. I don't think it has to be perfect, but we'll make a best effort here. I tried every different type of solder and flux I had in stock. I didn't want to buy anything for this, but don't have anything that seems to work on aluminum. All it does is just beat up and roll right off. So what I did is I cleaned the wire really well with some sandpaper to get all the insulation off, and I used some butt connectors that I had in stock. These guys here. So giving these guys a shot, and I put some heat shrink wrap over top of the butt connection because that's uninsulated. So hopefully this works. We'll give it a shot. Let's heat shrink wrap. Let's heat shrink our heat shrink wrap. Good enough. Sorry about that. Now we can start to wind things back together. This is going to be imperfect at best. And of course this thing comes up in a straightaway section. That's nice. This will be tedious. I won't bore you with this. And obviously it's not going to be as nice as a factory wind, but I'll do the best I can. All right, you can probably tell it's not factory, but this is the one I rewound. It's not horrible, not great. I got it started started to wind it right here, and then I'm gonna sand off this piece and put another butt connector on there. But first I think I'm gonna check continuity, which I probably should have done before I wound this thing. Make sure we haven't broken anything. And we're good, we're just under 5 ohms. This is how I've been preparing the connection, so I'm just using sandpaper to remove all of the insulation from the end of the wire. Because this is aluminum and it oxidizes very quickly, and the aluminum oxide does not conduct electricity very well. It's an insulator, in fact. Again, why use aluminum wire, but whatever. Now I'm going to use this dielectric grease. It's really used for cars. They make a product specifically for aluminum. I think it's called Noalox or something like that. I probably have some buried somewhere, but I'm too lazy to dig it out. Just put our crimp fitting on. Oh, we got to put our shrink wrap on first. Take our crimpers. We'll crimp on this end. and give her a squeeze. And then a tug to make sure it's secure, and it is. And then we'll do the same thing on this side. There's the other end of the wire, and this is the piece that we cut off like somewhere in here. I mean, it doesn't have to be exact, I hope. This is a washing machine, not a spaceship. So we'll just repeat that same process of cleaning off the insulation, using the dielectric grease to insulate the connection, and we'll crimp it on just like the others. Do another quick continuity check. This is the other end of that wire. It's about 65 miles long. Then we got this end here. Should get around 5.79. So perfect. I'll spare you guys the boredom of watching me wind these two coils. It's going to take a while. I want to do the best job I can. So, whoops! Make sure you drop your fluke meter. That's what they're there for. Anyway, I'll pick it up once that's all wound. All right, let's give her another check. So we got the meter here on ohms. Left terminal is 5.7 roughly ohms. Right terminal is 5.61 ohms. And the middle one, which is the one we messed with, is 5.74. So certainly within reasonableness. What I did is when I yanked this connector out here, I pulled the old wire out of it, and then when I rewound this one, and this one, I mean, it's not my finest work, but it is what it is, just strung the wire through this little plastic piece right here, and then just hammered down on that metal piece to anchor the wire in place and to split the, you know what I'm trying to say, to pierce the insulation. So I do have some extra wire. In reality, it's not going to make that much of a difference in the magnetic field, hopefully. Again, not a spaceship, it's a washing machine. So I think now the next step is, now that we've tested it, let's get it back in the machine and see if we still have a problem. Just for good measure, since I don't wind magnets as good as a machine, or as well as a machine, I put some hot glue in there just to mitigate any vibration or whatnot. I also put some hot glue on this wire nut here that holds the other ends of the wires together. Put some hot glue on this side too. Again, this is just for good measure. Hopefully the stator stays together a little bit longer than the factory one. All right, let's get her back together. Get this harness here. Get a couple of bolts in. Here's one. Alrighty, let's put our rotor back on. This is going to be a little tough because of the magnets, but we'll do what we can. There we go. Put our nut back, our bolt back on here. Again, just a 11/16 and 10 millimeter. All right, that's that. Let's fire it up and see if it blows up. Got the washing machine testing jig hooked back up. Let's power it up. Hello. All right, let's see it do something useful. Let's keep an eye on the tub. Tub is locked. It's thinking about something. Tub just jiggled, but it was doing that before. Oh, look at that. It wasn't doing that before. Wow. Is it going to add some water? Did I turn the water on? Yes, I did. Let this run for a little bit. And with the panel off, you can see it doing kind of cool things. Maybe. Come on, don't call me a liar. There we go. She's washing. That's what a normal washer does, right? It tosses back and forth like that. I wonder if we fixed it, guys. $0, just a lot of time. He's cooking. We probably want to be on the lookout for any strange vibrations. I'll let it run for a while and report back. The machine's been running great, so I ran it through a complete cycle with some close. It finished without issue, no strange noises, nothing. Now I'm doing a tub cleaning cycle, which is over an hour long. This machine's actually kind of cool. If you feed it cold water, it'll actually heat up the cold water and make it hot. I guess it's got a heating element built in. It's got a steam function, so it doesn't necessarily need hot water to make things hot. Like putting my hand here, that's pretty darn warm. I don't want to hold my hand on that for too long. So yeah, right now it's doing a tub cleaning cycle. We'll let it finish. Got about 56 minutes to go. So far so good, running great. Watch out, bud. Oh, that sounds like steam. Buddy, come here. It's kind of incredible how much soap scum builds up inside of a washer. So like this thing's running clear water right now. Look at all the bubbles down at the bottom there. Pretty neat. This cleaning cycle seems to work a lot better than the one on my top loader. All right, I've completed a bunch of wash cycles. I've done a couple of self-cleaning cycles. I mean, I've put this thing through its paces and had absolutely no issues with it whatsoever. So I think now it's probably time to button it back up. We still have this back cover off. If you recall, there were only 2 screws on it at the time. So let me get this thing spun around, unhooked from all the water and whatnot, and we will go ahead and button it back up. So my working theory on why this failed was a couple of coils on the bottom were discolored. I mentioned that before. And I don't know if you can see, but there's a faint water track or some kind of track here coming down here. And if you look at the actual drum itself, you can see some water tracks on here too. So what I think was happening was water was getting down here, dripping onto this stator, and getting onto the lowest point, which is right about down there, and just sitting there. And I don't know what this is, a vent of some kind maybe a steam vent, I don't know. But I'm guessing that a mixture of steam or cleaning water and detergent is getting down here, kicking up on that stator coil and causing corrosion. You can see further evidence of that on this cover. See right there? So that's my theory about what's going on and why this failed. If anybody knows anything definitively, certainly would like to hear about it. Have not worked on this model before, so if anybody has any history on this model, WM3670 HBA. So if anybody knows anything in particular about this model, would certainly love to hear it. Put our 2 screws in. I think there was one here. Stripped, of course. But the last guy used an impact driver. Good enough. Another possibility just occurred to me is maybe this hose was leaking because it's like kind of right under here, right? So if this was leaking down here, on the cold side, that might have the same effect in the long run. Alrighty, buddy, I think that's a wrap. So hopefully you found this video helpful. We saw an LE error code up on the display here, right here, when we tried to do pretty much anything. The customer reported that it was not draining, but there was nothing wrong with the draining system, at least not that I could find. So the issue is really with our stator. Our stator had open windings. We pulled the stator apart, pulled maybe 50 or 60 feet of magnet wire out of it, found the break, fixed it, put it back together, gave her a test, works great. So if anybody doesn't want to tackle that stator teardown and looking for the brake, they just want to replace the stator, I'll leave a link to the part in the description. So anyway, if you found this video helpful, please subscribe. Stay safe. Thanks for watching, everybody. Take care.